Complex numbers, part 2. What does conjugate mean? The opposite of the imaginary number. So you're taking the opposite of the imaginary number. Just to clarify what opposite means change a positive to a negative or a negative to a positive. And you want to change the imaginary number only. For example, example 1a, find the conjugate of a plus bi. The imaginary number is positive bi, so we're just going to change it to negative bi. So your answer is a minus bi. Example 1b, find the conjugate of 3 minus 2i. Here's my imaginary number. I'm going to change that to the opposite, so 3 plus 2i. C, the negative 5i changes to a positive 5i. So in these examples, I'm not changing the real number. Remember, example 1d, find the conjugate of 6. There's no imaginary number, so the conjugate of 6 is just 6. What does rationalize the denominator mean? Rationalize means nice number. Denominator means on bottom. Now remember, a nice number is not like, it's just something you can write as a whole number on bottom. For example, square root of 2 is not nice, but the square root of 4 is nice because square root of 4 is 2. And 2 you can write as a fraction, like 4 over 2 or 6 over 3. Also, when we talk about complex numbers, if you have an imaginary on the bottom, it's not a nice number. So anything that's real is not a nice number. So how do we rationalize the denominator? We rationalize the denominator by multiplying top and bottom by the conjugate. Example 1, 15 over 2 plus I. All I want to do is make the bottom a nice number. It's not a nice number right now because of the I. So I'm going to multiply by the conjugate on top and bottom. The conjugate of 2 plus I is 2 minus I. So just multiply top, 15 times 2, 30. 15 times negative I is negative 15I. Multiply bottom, FOIL it out. 2 times 2, 4. 2 times negative I, negative 2I. I times 2, 2I. I times I, negative I, is negative I squared. Alright. On top, I have 30 minus 15i. On bottom, the negative 2i's cancel out. I circle negative I squared. That becomes positive 1. So on bottom, I have 4 plus 1, which is 5. All I have to do is reduce now. 30 over 5 is 6. 5 goes in 15 3 times. Your answer is 6 minus I. Example 1a, I is equal to I. B, I squared. We all know I squared by definition is equal to negative 1. C, I to the third. Well, I to the third is I squared times I. Well, I squared is negative 1. Negative 1 times I is negative I. Alright, I to the third is negative I. D. I to the fourth. Well, we know I to the fourth is I squared times I squared. So I squared is equal to negative 1. Negative 1 times negative 1 is positive 1. So I to the fourth is positive 1. E. I to the fifth. Well, I to the fifth is I to the fourth times I. And we just figured out what I to the fourth is. I to the fourth is positive 1. Positive 1 times I is I. I to the sixth. Well, I to the sixth is I to the fourth times I squared. Well, we just figured out what I to the fourth is. I to the fourth is 1. And I squared is negative 1. So 1 times negative 1 is negative 1. G. I to the seventh. Well, I think I'm getting a little smarter here. I think I figured out a pattern here. I to the first is I squared is negative 1. I to the third is negative I to the fourth is 1. Well, I to the fifth was I, so it looks like it's repeating again. I to the sixth is negative 1. Oh, it looks like it's going in a pattern. So that means I to the seventh is negative I. So I to the eighth would be the next one over, which is 1. I to the ninth, it just repeats again, so it'd be 9. I to the 10th would be negative 1. I to the 11th would be negative I to the 12th would be 1, and it just keeps going on and on. So, question number 2, what is the pattern for I? Well, we should all know the pattern because we just went over it. The first one is, I'll write it down here. The first one is I. Okay. I squared, we all know, so the second one is negative 1, because I squared is equal to negative 1. And the other ones are just opposite. So the third one is negative I. And the last one is 1. And it just keeps on going on and on. Now, for the pattern, if you don't want to count so much, we're going to have to write remainder of 1, remainder of 2, remainder of 3, and remainder of 0. So if I had like a big number like 203, I would just have to find the remainder and start counting from there. And so if it had a remainder of 1, the answer would be I. If it had a remainder of 2, the answer would be negative 1. If it had a remainder of 3, it would be negative I. And if it had a remainder of 0, then the answer would be 1. So let's look at this in action. So example 2, I to the 13th. Okay, so I would write the 2a. I would write the pattern I, negative 1, negative I, and 1. Because you always start at I, because that's where you start at. I squared is negative 1, and the rest are opposites. So since it's 13, you can just count 13 times. 1, you start at I, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I to the 13 is I. Okay. Another way to do this, since it repeats after every 4, you would just take 13. 4 goes into 13 3 times. 4 times 3 is 12. And you have a remainder of 1. And you just count once. So here's 1. So I to the 13th is still I. 2b, I to the 6th. So I would write the pattern again. I. We always start at I. I squared is negative 1. And the other ones are opposite. So opposite. And opposite of negative 1 is 1. Count 6 times. 1, 2, 3, 4, 5, 6. So our answer is negative 1. Or the other way is 4 goes into 6 once with a remainder of 2. So count twice. 1, 2. And you would still get negative 1. And last one, 2c, I to the 203. So I'm going to write my pattern. I'm going to write my pattern here. I, negative 1, negative I, 1. I can count 203 times, but I don't think I can count that long. So I'm going to use the other way, the shorter way. 4, it repeats after every 4, so 4 goes into 203. 4 goes into 25 times. Bring down the 3. 4 goes into 3 0 times, so your remainder is 3. So I'm going to count however many the remainder is. Start at I. 1, 2, 3. So I to 203 is negative I. Alright. Thank you, and this is lesson complex numbers part 2.